Welcome back to another TOPDON Masters video. Today I'm going to show you how I built what's effectively the world's first thermal imaging trail camera. In this video I'll walk through the entire project from start to finish. I'll quickly reassemble the hardware, show the 3D design and 3D printed case, and explain how everything fits together. I'll also cover how the web app works, how I connected the camera, how the livestream is accessed, how recordings are triggered, and how all the footage is stored and managed. Towards the end I'll show real examples of the captured footage, including tracked videos and thermal recordings, so you can easily see how it performs in real-world conditions. This setup can be used in a lot of different ways, from spotting wildlife in forests to monitoring animal paths, feeding areas, drinking zones, and it can even be used as a security or monitoring system on farms or private land. This is a full build, explanation and demonstration of the system, so let's get into it. To make a TrailCam, we'll need two main things, a computer and a camera. On the right hand side we have a Raspberry Pi 5 which will be doing all the processing, and on the left hand side we have a TOPDON TC001 thermal camera. We're going to be using that to record everything and store it on the Raspberry Pi. I had a spare Raspberry Pi 5 case lying around with an integrated screen, so for now we're just going to be mounting the Raspberry Pi into that. Using 4 Phillips head screws, we're going to attach the Raspberry Pi to the base. We will now mount the 3.5-inch display onto the Raspberry Pi using the dedicated GPIO pins. Before we do that, I will attach a pillar screw onto the display to add extra support when mounted onto the Raspberry Pi. With the Raspberry Pi 5 acting as a computer, it will need storage. We'll use this SD card with a pre-installed operating system on it. The next step is attaching the top cover to the Raspberry Pi 5 while remembering to attach the power button to the Raspberry Pi 5 case. It can be quite fiddly, so it might take a bit of time, but make sure it's in the right place so that you can turn the Raspberry Pi on later. So today we will be using the TC001 for the thermal imaging trail camera. We will need to use a USB-A to USB-C adapter to plug the thermal camera into the Raspberry Pi. The thermal imaging camera can be plugged into the front and back port of the Raspberry Pi. Just make sure to plug it in to the USB 3.0 ports. Those have the blue plastic within them. For comparison, we can also use the TOPDON TC002C duo camera. It has the same size and ratio as the TC001, so it fits perfectly within our model. Similar to the TC001, you can also plug it into the front or the back port of the Raspberry Pi. After quite a lot of measuring, I was able to design a TrailCam case in Fusion 360. The TrailCam design consisted of 5 main parts: the base slider, the main body, a camera holder, a roof, and a display cover. Each component was designed to either mount on top or slide into each other. This meant that when the TrailCam case was put together, everything was held in place tightly. Then it was time to print. I used an Ender 3 Pro to print out all the sections of the TrailCam case. With the printing finished, we had all the parts: the main body, the camera case, the roof, the display cover, and the bottom base. The main body was printed in 2 main sections to avoid wasting filament on structural supports in areas that weren't needed. I welded together the 2 pieces using a soldering iron, melting the plastic in many different places. The Raspberry Pi, its display, and the case can now slide into the main body of the trail camera. On the side, I left a cutout to give me access to the USB-C port to power the Raspberry Pi later on. With the camera holder having to stay in place, I used a sliding mechanism to attach it to the main body. With the camera holder in place, I can attach the USB-A to USB-C adapter to the Raspberry Pi. When I slide the Raspberry Pi into the TrailCam case, the USB-A to USB-C adapter acts as a stop, preventing the camera holder from sliding out and keeping everything securely in place. With the Raspberry Pi inside, we can now slide the bottom cover to lock it in place. At the bottom of the slider, I left a hole to give me access to the power button of the Raspberry Pi. Now it's time for the most important part, the thermal imaging camera, the TOPDON TC001. And now we can put the roof onto the TrailCam. This will stop any water or rubbish falling inside when it will be placed outdoors. Finally, we can put the cover onto the Raspberry Pi 5 display. This will stop any light coming out and scaring any animals. Before I access the web app, I quickly go into my phone's Wi-Fi settings. You can see here that the TrailCam's network is already saved on my phone, so I don't need to type the password again. It connects automatically. Once I'm connected, I don't need to open a browser manually. On my home screen, I've added a shortcut called TrailCam Live, which goes straight to the correct URL of the web app. I just tap the shortcut, and it instantly takes me to the TrailCam interface, ready to use. Alright, so at this point I'm connected to the TrailCam's Wi-Fi, and I'm now on the main web app page. In the middle of the screen, you can see the live camera feed from the Raspberry Pi. Below that, there are 4 main buttons, and at the very bottom there are 4 information indicators that show the current system status. Before going into the files, I'll quickly explain what everything on this page means. First, we have events this run. This shows how many detection events have happened since the system was last started or reset. Each time something triggers a camera, this number increases. Next is recording on or off. This tells you whether the TrailCam is currently recording. If it says on, the system is actively capturing videos and photos. If it says off, it's live but nothing is being recorded. Here we have system disarmed or armed. When the system is disarmed, it won't record or trigger events. When it's armed, the TrailCam is actively monitoring for movement. The color also changes. Red means disarmed and green means armed, so you can instantly see the system state. Now let's look at the 4 main buttons on the page. These are Browse Files, Reset Background, Sync Time from Device, and the Armed and Disarmed button. I'll go through each one step by step. I'll start by clicking Browse Files. This is where all the captured media is stored and managed. The files are split into 3 sections: videos, tracked videos, and photos. First we have videos. These are the raw recordings captured whenever motion is detected. Each video includes a 10-second pre-recording, so you can see the animal or object walking into frame rather than only the moment after detection. Each video file is named using the date and time, so you can always know exactly when it was recorded. Every video has a preview streamed directly from the Raspberry Pi, a download button to save just the video, and a delete button to remove it from the device. Next is tracked videos. Tracked videos are the same recordings as the normal videos, but with an overlay added on top. This overlay highlights the detected objects and shows an ID number. Each new object detected in a scene gets its own unique ID, so if a second object enters a frame, it will be assigned a new ID number. This makes it easy to track multiple animals and objects in the same video. Finally, we have photos. Photos are automatically captured while a video is being recorded. In this setup, a photo is taken every 5 seconds during an active recording. This gives you quick snapshot references without needing to scrub through the full video. Each section has its own delete all button. Delete all videos, delete all tracked videos, or delete all photos. At the very top, there's also a delete all media button, which clears everything from the device. Next is a download all media. This automatically packages all videos, tracked videos, and photos into a single zip file and downloads it straight to your phone or computer. It's the fastest way to back up everything in one go. Now I'll go back to the main screen. Next, I'll demonstrate Reset Background. This button captures a clean reference image of the scene and uses it as a new baseline for motion detection. This is useful for lighting, shadow, or environment This is useful if lighting, shadows, or the environment has changed. By resetting the background, the system avoids false triggers and improves detection accuracy. Now I'll tap the sync time from device. This synchronizes the TrailCam's internal clock with the device you're currently using, like your phone or laptop. This ensures that all the videos and photos are saved with the correct date and time, even if the Raspberry Pi isn't connected to the internet. Finally, this is the armed and disarmed button. When I press it, the system switches between inactive and active modes. When it turns green, the system is armed and is monitoring for motion. When it turns red, the system is disarmed and safe to access without recording. Now that I've gone through the web app, let's look at the actual footage. What you're seeing here isn't being played through the web interface. This is the raw output laid out so that you can compare everything side by side. In the top left, you have the CCTV footage. This comes from a standard 1080p camera, which is roughly what you'd expect from a typical trail camera. In the top right, you're seeing the normal video recorded by the TrailCam. In the bottom right, that same clip is shown again, but this time as a tracked video, with the detection overlay and object IDs. In the bottom left, you have the photos that were captured automatically while the video was recording. For this current version of the TrailCam, you may notice that the thermal video stream appears slightly unstable with flashing horizontal bars in the image. This is caused by power and processing noise when the video is being handled directly by the CPU rather than the camera itself. This is a known limitation of the first edition, and is something that is being addressed in the next revision of the trail camera. With the CCTV camera, you mostly see the eyes. That's because CCTV uses infrared vision, and animals' eyes reflect the infrared light back towards the lens. So at a distance, the eyes stand out, but the rest of the fox is hard to see. When the fox moves, you might notice lines coming out of the eyes in the CCTV footage. That doesn't mean the fox's eyes are actually stretched out. It happens because the camera uses long exposure and blending multiple frames together. As the fox moves, the bright eye's reflection leaves visible trails. With the TrailCam, it's very different. The TrailCam detects heat, not reflected light. Because of that, you can see the full body of the animal, not just the eyes. Overall, the TrailCam gives a much clearer picture at night. You can see the animal further away, and you clearly see the shape and movement instead of just eye reflections. And before we finish, I'll be releasing another video in the next couple of days showing the full recorded footage from the TrailCam, basically all of the events and captures from this setup, so keep an eye out for that. And that's the first look at the TrailCam project, from the web app to motion tracking to the final footage. Right now, I'm working on designing a better case and adding a small integrated display that acts as a heads-up display, alongside a more tightly integrated web app. Another project I'm developing is a TS004 TOPDON thermal monocular mounted on a DJI Ronin SC, turned into a wireless, computer or phone controlled turret, with auto tracking as an optional feature. These projects are coming out in the near future. If you've got any questions, ideas or recommendations, drop them in the comments. All of the files for this project are available on the TOPDON community page, including a link to the GitHub repository. The GitHub contains all of the code used to build the TrailCam, as well as the 3D printable files for the case. Thanks for watching, and see you in the next one.